All right, let's get to it on 26. Okay. All right, so find the slope of a line that's parallel. All we really have to do here is actually find the slope because parallel has the same slope. So we have the formula from up here, y2 minus y1, x2 minus x1 for slope. So we'll just use that, negative 5 minus 5, and negative 7 minus a negative 2. So negative 5 makes negative 10. These two negatives become positive, so I get negative 5. That becomes positive to give myself 2. Since it's the same slope, we just use 2. Number 27, write an equation of a line that's parallel to this and goes through a point. So first we have to find the slope. To find the slope, we're going to subtract 2x. We get 3y equals negative 2x plus 9. And then divide by 3. So we get this equation. And the key here is we just need the slope from this. And since it's parallel, we're going to take the exact same slope and the point. We're going to put it in a point slope form. Okay, we used point slope form earlier, which is right here. Y minus y1 equals mx minus x1. And so I'm going to get y minus y1, which is 1, equals the slope, which is negative 2/3, and x minus 3. So I'm going to distribute this to get negative 2/3 x, and then distribute that. The 3's will actually cancel. The negative 2 times the negative 1 then will become positive 2. We just add the 1 over to get negative 2/3 x plus 3. Alright. 28. D and E are perpendicular. So this is E and this is D. They're 90. And then F and E are perpendicular. What must be true of D and F? Well, those two would have to be parallel. Yeah, this is the same pen I had trouble with last time. Okay, so D is parallel to F. There we go. Woohoo! Alright, use the figure to find the missing angle measures given L is parallel to M and A is parallel to B. So 126, basically, I just go like one thing at a time. So here, I see 126, angle 2, those are corresponding, so they're going to be congruent. So angle 2 is 126. And then to find the rest of these is really easy because 4 is vertical, that's 126. And then 1 and 3 are supplementary to 2. So we just have to say what plus 126 equals 180. That's going to be 54 and 54. And I'll just put 1 in for now. It gets a little messy when you plug them all in. Then we go this way, and I see 2 and 6 are corresponding. And so that means 6 is 126, and its vertical angle 8 is also 126, and then 5 and 7, the same thing, are supplementary, so 5 and 7 are 54. And then last one here, 6 and 10 are corresponding, so they're going to be congruent, and 12 is vertical, so that's congruent, and then 9 and 11 are supplementary. So all the answers are 126 or 54. Just make sure you get them in the right order. That's the key. Okay. Next, let's go with 30. These two angles are corresponding angles, so they should be congruent given parallel lines, and so we set them equal to each other. 2x minus 42 equals 3x plus 2. I'm going to subtract this. That will leave me with x. I'm going to subtract that. That's going to leave me with negative 44. Not the greatest answer for logic here, but it does work. Okay? Okay, let's go ahead and continue. Alright, 31. So these angles are not corresponding, but they're on the outside and they're alternating, so we call that alternate exterior. But, like corresponding, they're congruent when we have parallel lines. So we're going to set them equal to each other. Subtract it, we get 2 equals 2x minus 34. Add the 34, we get 36 equals 2x. And divide by 2, x equals 18. All right, number 32, a couple ways we could attack this problem. The first way is we do know these are parallel. This angle here and these two angles here are alternate interior. So I could set 30x equal to 102, which is the way I would do it. I had some students find this angle because these are 180, and then those two should be supplementary because they're same side interior. But I find this one to be slightly faster. Okay, and we get 34. All right, number 31. 1 and 7, they're unparalleled, they're alternate exteriors, so we can prove, since A and B are cutting L is cutting A and B, we could say A is parallel to B, and justification would be converse of alternate exterior angles. 9 and 11 are vertical angles, so there's none on that. You can't prove lines are parallel with verticals. Vertical are all over the place. And then 8 and 9 are supplementary. If you look at this, 8 and 9 are same side interior. They sit on L and M, and they're cut by B, so L would be parallel to M, and that would be converse of same side interior. All right. 36, explain the difference between the types and draw a picture. So isosceles has two congruent sides with two congruent base angles and what we call a vertex angle. An equilateral has all congruent angles of 60 and all congruent sides. And the scalene has all different sides. What type of triangle has a hypotenuse? That would be a right triangle. Okay, draw the triangle. And the hypotenuse would be this one. It's across from the 90. What type of triangle has a vertex angle? That would be an isosceles. I'm not going to draw that one because I just drew it right there. Pointing to the vertex. What does CPCT stand for? It says corresponding parts of congruent triangles are congruent. When we use it, after we prove a triangle congruent. I cheated on that one, but there we go. Okay. These two segments are congruent, so we're going to set them equal to each other. We subtract 3x, 14 equals 4x minus 2. And then add 2, you get 16 equals 4x, and then divide by 4, x equals 4. This next one, we have an isosceles, which we have two congruent sides. That means the base angles are going to be congruent as well. Now I know all three angles. We can set them all up, add them all up, and equal to 180. Okay, because we know all three angles of a triangle add to 180. So 3 plus 2 is going to be 8y equals 180. And 180 divided by 8 is 22.5, I believe. All right. 10 to go. AED is 2x, and AEG is 5x minus 2. Those are a linear pair, so we can add those together and set it equal to 180. It's going to be 7x minus 2 equals 180. Add the 2 over, 7x equals 182, and then divide by 7. X equals 26. Number 42, the figures below used to solve for x. This angle and this angle are congruent because these are congruent sides. These must be the congruent base angles, so we just set them equal to each other. I'm going to add the 18 over, subtract the 2x, x equals 18. These ones can go kind of fast. We have two congruent base angles, which means the opposite of this one, the two sides must be congruent, so we can set those equal to each other. Subtract the 2x, we get 3x, minus 8 equals 10. Add the 8, we get 3x equals 18. Divide by 3, x equals 6. Number 44, use the figure below to solve for x. Okay, well, we know all three of them add to 180, but if I took the 90 out, these two would have to add to 90. So we can just set these two and equal them to 90 if we'd like. It's going to give me 3x plus 30 equals 90. Subtract the 30, we get 60. Divide by 3, we get 20. And if ABC is equal to FGH, what would GFH? So we just line up. G and B match, so the first one would be B. And then, let's see, H lines up with C. And then the last one we have left is A. 5 more to go. We got this. Determine if the triangles are congruent. This is some of the most missed questions because students will mark things that they think is true, but not necessarily true. So AB and CD are congruent. AB and CD are parallel. I do have this piece is congruent because it's shared, and then I have alternate interior angles. So this is actually going to be side angle side. You can see that, side angle side. That's still pi. Then we just got to match. Okay, so A is going to match with C, B is actually going to match with D, and D is going to match with B. And 47, RC is bisecting HRT, this large angle, so those angles are congruent. H and T are congruent. And then we have our shared side, so that's going to be angle side, because the side is not in between the two angles. So angle side, and then we have, let's see, R matches with R, T matches with H, and C matches with C. Okay, what properties can we help for prove a parallelogram? We could do a couple of different properties. We need to have congruent opposite sides, but not congruent diagonals. There's lots of ways to prove, but that's one of them. Rectangle would be congruent opposite sides and congruent diagonals. So that would be the difference there. And a square would have 4 congruent sides and congruent diagonals. And that's 1 through 50. Well, if you watch that video. Alright guys, so thank you so much. Goodbye.